Welcome! We are Drag Aerospace, and through a collaborative effort between SCSU, Space Labs, our sponsors, and Dr. Bonnie Yunez, we are on a mission to take high-definition images of possibly habitable exoplanets far beyond our solar system, up to about 30 parsecs away, using the gravitational lensing effect of our sun. Let's go ahead and take a look at our model. Here we have a model of our exoplanet imaging telescope. The goal of this model is to prove the underlying principle that our satellite will continuously point towards the sun. Up next, we'll show you some inside components of how our satellite works. In order to prove our telescope's sun tracking capabilities, we have decided to make the simplifying assumption that our model will follow a single axis of rotation design. That is achieved through our turntable on the bottom. For our model, in order to determine our sun tracking capabilities, we have decided to use two photovoltaic sensors, one on the left over here and one on the right over here. Now, our satellite is programmed in order to determine the difference in light sensitivity, thus giving us a direction in which to point our telescope. In order to most closely resemble our satellite's true dynamic nature, we have decided to use a pneumatic solenoid approach. Up on top here, we have an air tank, and we have a pressure regulator here. It goes down through a pneumatic line, and on the four corners at the bottom of our satellite we have four solenoid valves that are activated through our Arduino. In our model we have four major systems, the first being the pneumatic system pictured by our air tank and our air lines on the left hand side. We have our propulsion system, which is four pneumatic solenoids on each corner of our satellite. We have our power system, which is our battery here along with the connector on the left. And finally, we have our Arduino and breadboard pictured here on the right. Now, assuming that our satellite has been deployed and is en route to the SGL location, we assume that our satellite is pointing in the general vicinity of the sun. Now, with our sensors, we are able to make fine-tuned adjustments to ensure that we are always pointing towards the sun. You can see here that we're going to move to the left and to the right and back to center. And we're using the phone's flash as our sun. We are Drag Aerospace. We want to thank Dr. Bonnie Yunez, SCSU, Space Labs, and our sponsors for making this happen. Please, any questions or comments?